Hi everyone. Today we deal with weird files and how to make them with Mitra. So, generating weird files and weird files in general. So, Mitra is my tool, Corkami, GitHub Corkami Mitra. Yeah. Oops. Come on. Yeah, so the address GitHub Corkami Mitra. My speaker deck, I have my slide deck will be on speaker deck. The new one is the version 2, which is slightly updated. And then I will also, if you're into academic papers, then in the 2020 paper about how to abuse and fix authenticated encryption without key commitment, it's a cryptographic paper, but I also introduce a lot of stuff for the first time in the academic world regarding file format structures. So basically, if you're into academics, this is the way to basically these two things: the generating weight file slide deck and the 2020 paper on key commitment are basically the two cousins on the same topic. So again, as I mentioned, Mitra is the tool that I created for weird files. It comes with a lot of single files, test files that I created mostly by hand. You've seen a few of them already, like this PNG. Just you probably, if I have to zoom a lot, but it's basically a minimal PNG of 122 bytes, just to show. I mean, to test that the file is working, but I ended up doing that with many other formats. The Photoshop is bigger, so for some reason is zoomed in a bigger way. 572 bytes. Okay, you get the idea. So basically, and there are also tools that are related to other attacks, including the key commitment ones in the tools repository for stuff about manipulating files with crypto. Anyway, so that's the introduction of Mitra. And but first things first, let's go. Bonsoir, Henri. Let's go through the slide deck. And yeah, so that's so basically there are several topics in this presentation about me, mostly about Mitra, but weird files in general. And again, there are different depths of file parsing. I think it's very important. Sometimes you just want to identify the file, and sometimes you want to just validate the overall structure, and sometimes you want to instead parse every element of it. And sometimes printing takes even more things into consideration than, for example, viewing, or the same as displaying the content on an archive and actually extracting everything. So there are different depths, and depends what you want to abuse, but sometimes you just need to abuse identification to fool a parser, and that's all you need, because the identification leads to the background process of security scanning, for example. And again, yes, with each depth comes also a different possibility of abuse. So if you want to add a fake magic, you want to that's what I call polymocks, mocks and polymocks. Or you may want to store extra foreign information, like just a PHP JavaScript payload or something, or hide some content. But you want to also create a file with two file types valid at the same time. That would be then it's a polyglot. And but then this can be done generically, and this is exactly what Mitra is about. And then there are the more complex cases of hash collisions and near-polyglots, but I will not address those tonight, most likely. And for parsers differences, then ambiguous files and all this kind of weirdness, I fought this afternoon with a lot of parser differentials. Yeah, it's then it's case per case, while the most of what Mitra does is based on the characteristics of the file format, not parser differences. So if you just want to, if your file abuse doesn't have a new full format, just a magic, then it's a polymock. Then if it's the same format twice, then either it's ambiguous, and then okay, near-polyglot, I won't deal with that today. But for all these kind of abuse, then what is important, okay, I gave some talks on the topic in the past, and today I cover Mitra and its little brother Moki, which is basically using Mitra engine. And yeah, so that's Mitra. Just comes with the famous polyglot Greek character, and it's a very easy file tool that just takes a command line to draw up. Does it work? Yes. Oh, I have a typo in my Mitra. Oh, okay. Mitra.pdf.py. And if I do, Mitra input dot decom.png. This no, no, wrong backslash. Sorry, decom and input png and okay, of course. And yeah, and it creates a zipper of the file. It just identifies there is a verbose. No, there's no verbose. Okay, version. Sorry, there's no verbose. There's no verbose flag, or was it in my imagination? Do I know my software? Exactly. So it's trying different strategies, and it's trying these different strategies, and it's how can I say? Then it's trying, this can be appended because of these rules, and this cannot be file start out, offset out less, and then it's trying, and it's giving you some information. So we will see that Mitra has a few strategies. It just knows the bare characteristics of each file format, and then it will try to craft a file if possible. It's not guaranteed to work, but yeah, that's still you'll get an idea after this stream. So the concatenation is the very classical appended data. So you have a first file type, first in offset order, that must tolerate appended data. The DCOM, which is a medical image format, doesn't tolerate appended data. And type B must be allowed to start at offset size A. So here it's a bit interesting, because I just made Mitra generate as PNG DCOM polyglot. PNG start at offset 0. DCOM start at offset 80 in hex. But DCOM doesn't accept appended data. So therefore, you have to put the rest of the body in the, here there is a PNG comment that Mitra generated, and you have the length here, and it will cover the whole DCOM preamble, the end of the preamble, the header, and then a declaration of I forgot how it's called in DCOM segment or whatever, to cover the rest of the PNG image. And PNG image themselves tolerate appended data, and then here resumes the DCOM file. So that's why it makes this file working. This is not a trivial case. It's not that complex, but it's definitely not a trivial case, as opposed to, like you just take Mitra again, and you just say PNG input zip, and it should create two different kinds of files. One where there is a zip, the PNG, and as it says, the zip in this case is the zip in this case is a parasite of the PNG. So the zip is inside the PNG, and the other one is just stacked next to each other. So this is the concatenation case that we are working that I'm mm, presenting now. So the first file type, for example, PNG, must tolerate appended data, and file type B must be allowed to start at an offset. Like zip, we saw, can be put at usually any end of the file because it's parsed bottom up, but it's not entirely true. And yeah, there's basically some requirements because some formats you sometimes have to start at a specific offset, like PDF, for example. So the idea is simple. You just relocate the one that can be coming next, and you append both. And most of the time, these don't require any data update. Even though I mentioned that zip may work with absolute offsets rather than relative offset to the signature. So that's just a simple polyglot by concatenation. So polyglots, it's an old trick that still works. Jar appended to MSI, or it was still working, and there are still some cases. There are even polyglots that exist clean in the wild, like the hybrid ISO, which have bootable ISOs, hybrid PDFs from OpenOffice that are just a PDF with the original document embedded in the PDF, so that you have a public imprintable document without anything but a PDF reader, but you still have the original file available. And maliciously, polyglots have been used. GFAR, one of the original polyglots in the wild, was in 2008, if I recall correctly. So okay, so if when you create new file format, please enforce the signature at offset 0 to prevent further polyglots. Now cavities, another very easy case, but sometimes it's not so easy. I mean, so ISO and DCOM are two formats that are known for starting with empty space. I mean, ISO is like a 16 sector, so it's a lot of space, and DCOM it's just 128 bytes, but usually you have some messages or whatever metadata, so you get the idea. So basically, there might be some space before the actual start of the file that could be exploited. So basically, you just have to know if the first file fits in the cavity, and then that's pretty easy. That's all. Again, the file I showed earlier with the DCOM and PNG is more complex than that. Polymocks. So the principle of file types identification, like from tools like file, is that they are scanned by category in alphabetical order. So basically, Acorn file types will be identified before Windows. And there are a few sometimes there are images, but if it's a DOS or if it's a Windows or whatever, it can be, it's not entirely always easy to, since there are some categories that are OSs. RIF is the container. It's not exactly homogeneous, the way that the magics are organized, classified. Question: the difference between that cavities having fixed lattice bounded size? Yeah, I mean, in the case of DCOM and ISO, the cavities have a very strict. Yeah, they're always at the same place. PDF, it's not clear if it's a cavity. I mean, it can be seen as a 124. I mean, it's 120 something bytes cavity, but it's variable, so it depends. But yeah, it's just that if people forget about ISO and DCOM, it's not a very common characteristic of file formats. It's just making things easier to abuse. And yes, there was a CVE for an MZ executable being a also a DCOM image. And yes, you could. The example was just putting WannaCry in a DCOM image. Mock files is a bit. I mean, again, what do you put in this space? You can put an entire file, but what if you just put a magic? So I created a crazy file I think I initially started that one by hand, and the file should be public, right? Oh, the file is on VirusTotal. Okay, I'm pretty sure it's on my. Oh yeah, it's polymocks. You have this it's on my GitHub, one of my GitHub, and you have this source where there is a lot of a declaration with a lot of signatures that are extracted. So some signatures cannot coexist because, as you can see, hope you can see. Let's zoom a bit. Some signatures start at the same offset. So I took usually the most widespread one, but there could be more of them. And so basically, this tool generates this file, which contains a lot of this source, which contain a lot of magic signatures. To make mock files, so it's easy. Just you just can use this file as a reference or the libmagic source, and then you will see what file type will be identified first by libmagic, and therefore you can easily insert a signature, and then libmagic will fail a file will fail to identify the file with the expected format, even though there is just a signature. So parasites starts to get more interesting because the first two are very standard case, like appended data and cavity. Appended data is very common in a lot of formats, and cavity is not so widespread. So that's the obvious ones. And parasites. So one host type must tolerate parasitizing data, and typically there is a length restriction, especially because of the way the size of the command or whatever space you will abuse is stored on a given number of bytes. And then there is the type that the parasite type should be allowed to start not too far in the file format. So basically, you make room in the host file to declare, for example, like declaring comment to put the final payload. You relocate the payload. Again, relocating may require nothing, or it might require adjusting offsets or these kind of things, or checksums or whatever, or turning the file into another file that is easy to be abused. That's something I'll discuss a bit later on. And then you combine both. And usually it's pretty straightforward, but sometimes it's not that easy, especially when with variable integers or the file size, the parasite size is declared on a variable integer. People sometimes are shocked that you can add parasites in a file format, but it's a normal feature because you just want people to be able to add whatever extra information they want, thumbnail or whatever. And that's the thing, right? If they are part of the format, at least it's known that they can be there, and at least it's known that it can be removed, merged, scan, whatever, and the file would still work. So it's actually it's not a risk that there is such an ability. It's a standard thing, and of course you could still check that these comments, which in general I call blind spots for the parser, if they are single comment or small and pure text, then it's probably fine. And if they are several or many, and they are maybe big and they have a high entropy, then maybe it's suspicious. So scanning those is not necessarily a problem in general, and is a normal feature to have in a file format. So parasitizing has a few comes with depending on the structure of each file format. And if you see, so I showed that a bit more in the, if it's like a train where you imagine you have a locomotive and wagons, then just add a wagon, like the chunks of a PNG, add the wagons and update the wagons counter, and your train is one wagon longer and it's still a valid train. If your if it's like an archive of, there is no locomotive, basically it's just a box next to each other like frames, then just add a new box. So these are for the formats that have frames like OGG or WavePack, where basically you just have to add a new frame, or what is it, was it Z standard, You just, hey, here is my parasite hosting box that I will just call differently, and it's just another box in between other box, but there is no counter usually, and there's no something like a header, a locomotive, or whatever. You get the idea. If it's a book, so some like there is a table of content and there are pages, then it's when there is a cross-reference table and there are pointers, then just add the objects and then update the table of content. And sometimes it's instead one object points to the next and so on, and just instead of having objects following each other, just create some extra gap and put a parasite, maybe undeclared, between the two boats, two towed boats. In this case, the parser will not see that. It's not officially declared in the chain of boats, but it is. It might still work as a strategy for to put some parasite payload inside the file. Okay. Sometimes some file formats have a very different forms, and can be a pain because you would end up having to abuse all of them. And some stuff is complex, like palettes and linearization and versions. So it's definitely worth trying to find the right method to normalize, to turn all possible input into a form that you can abuse. And this is exactly what I'm doing with PDF in general. The standard old school form is much easier to abuse than the new ones, and basically just convert them with a trick, with a tool, or if possible, not. If you don't even have you to write yours, it's even better for better compatibility. So some file formats don't tolerate appended data. There are few seconds of junk, for example, until the end of file, like pcap and decom. Oh, not junk, chunk, sorry. And some parser just reject if there is something that is found behind the terminator, like BPG and Java. And some rare formats enforce a footer, and basically the end of the file should finish in a very specific way. And in this case, you cannot append data, which is the exception, but there is still a possibility to uh, wrap the appended data in a trailing chunk, which hosts the parasite, and I call that wrappending. So this is what I did with decom earlier. And now let's get a bit more difficult. Zippers is just that you know what a zipper is, and it's or there are plenty of names even for that in French. Uh, and basically, each side embraces the other and comments out the other side. And without having to do that too much, you can a simple zipper as a file format is just combination of about two formats, and basically there are two heads and two bodies for each side, and one head is a parasite for the other side, the other body is a parasite for the first file, and then the last body is wrappended or appended to the first file, to file A. So you get the idea with the schema. And how is it helpful? It's when, for example, the parasites of the file format are very small, like for GIF, the parasites can only be 255 bytes consecutive, which is extremely limiting. So you could only, it looks like you could only hide a payload that small. But then if you can just declare a header and some command declaration there in this 255 bytes, then it sounds very possible, and you can abuse that. Then what if the other format has a cavity and makes it possible? So basically, this is a bit more complex construction. Just enable even more compatibility of polyglots between between specific file formats. So you take the first file. There is one with a out of set 0, and then there's the one that has a cavity that can start late, or at least can start later. And you parasitize both side with another piece of the other side, as you can see, and then you try to merge that and get everything aligned. So again, zippers are good for overcoming constraints when some formats don't look easy to abuse. As a result, Mitra already handles all these file formats, and you can see the possibilities. Some of these tricks are a bit tricky, but you can see that basically it depends on the characteristics of the file format. If the magic signature is enforced at offset 0, then polyglots are not possible. And format with cavities enable more stuff, and format valid at any offset is definitely the most permissive ones. And the one that enforce the footers are usually really giving troubles. So Mitra could sound like a very complex thing, but it's not really, because you don't have to fully understand the file format to abuse it. Just have a look for specific characteristics and try and play with it. And yeah, then it might be enough. And that's more or less what Mitra is doing. A very light identification, then just try and doing stuff together. So looking for this characteristic, what's the magic, what size is it, what's the minimum, what's the start offset for the file, for the format in the file, is there a cavity, are there possibilities of parasites, and appended data. Mitra is a simple tool. It expects standard files, surprisingly, and it doesn't valid output files either. So for example, if you want to abuse JPEGs like Mitra the laziest possible way, just look at a small JPEG file in the easiest way, and basically, JPEG files are made of segments with a FF and then a marker that is always non-null, and often there is the length of the segment on 2 bytes right after the marker. So some segments don't have a size, and some don't have so the start of scan has a size, but the size is only 8, is only the size of the parameter before the compressed data. So basically the size here is not the size of the whole segment. And you can insert another segment, a command segment, with FE as a marker, and then there's a length again on 2 bytes, and then you can put whatever you want. So basically, you just need to identify that it's a JPEG, then says, hey, this is exactly the source in Mitra. And then you say, hey, it allows for parasites. These are the minimum offset and the maximum size of parasites. And this is how you create a new parasite. And that's all. That's all Mitra knows about JPEG, and yet it works because that's all he needs to do. And it doesn't specify that JPEG supports appended data because that's by default. Most file format tolerates appended data. So there are POCs, docs, and so on. And yeah, so what can you do with Mitra? So for example, before anything like polyglots, you take a script, it could be JavaScript, and you use with Mitra, but in this case, you just say, hey, force that it's a blob without knowing, because otherwise it will reject the script.js file format by saying, hey, I don't know what this file format is about. And then just say, take it as a binary blob, put it inside. And as you see, it took the PNG file, created a command, and put the whole script inside. There's no JavaScript in. Okay. There in the case of in the page of Mitra, it's the. Oops, this is very big now. This is the HTML payload that is on the side, but I mean, you have a lot of samples. You see what I mean? So that you can do that, and then you can try it yourself, and it will just create a PNG that is still valid because it inserted a command in a chunk in the sequence of the other chunks. And yeah, so if the JavaScript payload doesn't work, if the HTML payload doesn't work, that's your problem. But at least Mitra will be able to help you by, like, hey, this is the format and this is what I can do with it. Moki is just about inserting payload in a file. It's inserting something in a file, but it's inserting other signatures. And Moki has this signature. Moki is there. It's just using the engine of the format, and all the signatures are in this file, and then you have a lot of them again extracted from libmagic. Um, Very important, you can just say moki and combine, and it will try to add as many signatures as it can for this format. And then you see what file tells about this file. And one very interesting thing with tar files is that tar have this checksum, and file libmagic is checking for the tar file type before other file types because it's an archive, but it needs that the checksum to be correct. And because Moki handles that, here you see tar checksum, then it's very likely that if there is a possibility that there is a valid tar magic and tar checksum being added to the file, then when you scan it with file, the file will be seen as a tar archive first. Of course, if you do file, you scan with file with the keep going parameter and raw, I mean raw just to for new lines, then it will still see the other file format that were inserted, but again it will still see the star archive first, and the file is still valid because in this case it's just so okay, let's see. Okay, Moki, oh sorry, moki.py input with dash dash combine and input JPEG. Yeah, there we go. It gives us a file, and if does that work? My file is called that, and it's star archive, and now we can see the file. So again, the original JPEG file is this, beautiful. It's a JPEG. This JPEG is a bit big in size because JPEG is working with 8 by 8 blocks, and therefore I made this file 8 times bigger so that the boundaries of each block are on. So this is why it's quite big in size compared to usually, but this makes it compress more because again each block has its own parameter basically. So if you do a JPEG file that is as small as possible, then the file will compress less in this case. I think that was the idea, and that's the file, and that's just a very tiny JPEG, as you see. Oh yeah, so basically now all these are just no compression, and the no compression comes because each block, the boundaries of each block is perfect. So basically, you can say, hey, the file will actually get smaller with a very clear. In this case, I think the PDF is lossless because the compression is 100%. And it's probably a grayscale JPEG in this case. So you see a very small JPEG, and yeah, just very nothing special. And now, if we look at the file that was created, then just after the JPEG signature FFD8, then we see command declaration. Here is the length, and here is the rest of the chunk. And you see that Moki added a lot of signatures, including tar checksum here, 2, 5, 6. This is a tar checksum, and there is what is interesting. Well, there's the DCOM signature here, the DICM. The others, you probably, I'm not sure which one is very very common, but basically this yeah, and there's a 55AA from the master boot record because why not? And yes, and then ends the JPEG file resumes. So basically, this JPEG file will not be will still be valid, of course. There's nothing that should prevent it to work, but now it's being detected as a so key, yeah, key is being detected as many file formats by file, even if you just if you so basically it still says that it's a JPEG file, but this is the fourth file type that it checks. So Moki did its job, and identification is easily fooled in automated way. When you want to generate a polyglot with Mitra, sometimes the order of file arguments matters, because it will say, again, if there's concatenation, that the first file type you give is the one that will be first in the file. And basically just try with the reverse parameter to just try both sides if you want. And okay, so not sure I should cover near polyglots now, because then there is some crypto stuff. Yeah, just I will just introduce near polyglots as saying that sometimes, for example, there is no PNG BMP polyglot because they both start at offset 0. So there cannot be a file that is a valid PNG and a valid polyglot at the same time. But the idea would be, what if we could put some data somewhere else and that could be replaced? So it's a near polyglot, and basically you just replace some data with an operation, and this data could be what was called encryption. So basically, abusing CBC cryptographic modes and other modes, or the paper here, like ASGCM. But that's another thing that's totally not the same attack, but it still relies on Mitra and crypto-polyglots. Oh yeah, I call that crypto-polyglots when the near polyglot, the operation is replaced by a cryptographic operation. But that's not for today. And but yeah, just that you know that Mitra is definitely helping for that. So with the overlap parameter, it will create a near polyglot, and then with some extra tools, then it will actually, that are actually in the Mitra repository, then you can have a BMP file turn into a PNG with arbitrary payloads. I mean, with the payload that you chose in the first place, with some specific parameters. And the same for example, here a BMP page, a BMP and PostScript file. So here it's a near polyglot with only 3 bytes of overlap, because PostScript is pretty permissive. And actually, I'm thinking it could be 2. I should check. Now I'm thinking maybe it could be only 2 characters. Interesting. I should check. Maybe. and yeah, so basically here it's about we would have a given ciphertext that would decrypt with 2 keys in an authenticated way to both payload, to either payload, depending on the key. And there is even a near polyglot. You can see a near polyglot if you hash collisions with chosen prefix could be seen as some kind of crypto-polyglots with a huge overlap. But yeah, still it's the same idea anyway. So yeah, I didn't give this example that if you just I mean, because now Moki is making it very able to easily add a lot of signatures at once. Yeah. So, and if you think that all new formats still always have a magic at offset 0, that's absolutely not the case, sadly. So, any questions, people? Oh yeah, there is. So Mitra files have a very weird name because if you saw earlier, that's the let's see. Okay, I don't know if you see the name of the. Let me say. I will drop the file names of the 3 Mitra files that I created earlier. And they have very weird name because this means this is a parasite, and here are the offsets where the payload changes size, I would say, and this is a PNG hosting a zip. This is a stack, so concatenation, and same thing, the offset where the content change types, and then this is a PNG followed by a zip. And this is a zipper, and again, same idea. So that's why they have a weird name. And when there is a near polyglot, then I added the overlap between curly brace, so that tools can generate next, recreate with the cryptographic operation the proper overlap. So that basically, overlap creation is automated. And to be honest, this paper here, our paper on key commitment, is actually a crypto-polyglot. And if you run OpenSSL on it, it will the file will this file itself is a polyglot. Where do I have this file? Here. Oh yeah, but maybe that will not be very visible, because here you see some random data after the end of file, because that's the AES-GCM tags, if I recall correctly. And yeah, well, definitely not. I will not cover in this stream. So, do you have any questions, everyone? Let me know if you have some specific polyglots that I should go through, or that was a bit too difficult, or maybe now you have a lot to read. I went through the, yeah. Don't. I don't understand the whole cryptographic part of this paper, right? I'm just responsible for most of the file format tricks. But yeah, I guess that's, if I have no question, then I think that's good for tonight. And I thanks for your attention. So yeah, thanks for your attention, everyone, and see you next stream.